You know what's wild? Your Netflix recommendations get better the more you watch. Your phone learns your face even when you grow a beard. Spotify somehow knows you're in a breakup before your friends do. And here's the thing that nobody really talks about. These machines aren't following some giant rule book. They're making mistakes constantly. And those mistakes, that's exactly how they get smarter. Think about that for a second. We spent centuries trying to program computers to be perfect, to never mess up, to follow instructions exactly. And then we discovered something that completely flipped everything upside down. The secret to making machines intelligent wasn't making them perfect, it was teaching them to fail better. In the next 15 minutes, you're going to understand how machines actually learn from their mistakes and why this changes everything about what's possible with technology. Because once you see how this works, you'll never look at your phone the same way again. Here's what's really happening every time you unlock your iPhone with Face ID. That little camera isn't just checking if you look like your photo. It's making thousands of tiny guesses about what makes your face uniquely yours. And it's wrong. A lot. Like, constantly wrong. But every time it messes up, every time the lighting is weird, or you're wearing sunglasses, or you just woke up looking completely different, it gets a tiny bit better at recognizing you specifically. Picture this scenario. You get a new iPhone. First time you set up Face ID, it takes like 5 seconds scanning your face. But here's what Apple doesn't tell you in the commercials. That scan, it's basically creating the world's worst version of a U detector. It barely works. If you tried using it right then in slightly different lighting, it'd probably fail half the time. But then something fascinating starts happening. Every single time you unlock your phone, that system is taking notes. You unlock it first thing in the morning with your puffy sleep face, it learns. You unlock it in your car with sunlight streaming in from the side, it learns. You unlock it at a concert with crazy colored lights, it learns. Each mistake, each time it almost didn't recognize you but did, or each time it hesitated makes it smarter about what you actually looks like under every possible condition. Everyone tells you that AI learns from data, but that's not the full story. What really happens is way more interesting. These systems learn from being wrong. They learn by comparing what they predicted would happen versus what actually happened. And the bigger the difference between those two things, the more they adjust their understanding. And this matters because everything you think you know about how computers work is built on the old model. The model where you give a computer perfect instructions and it follows them perfectly. But we've entered this completely different era where the most powerful computers in the world, the ones deciding what you see on Instagram, translating languages in real time, driving cars, they're all operating on this principle of beautiful, productive failure. It's not just about getting better at one thing either. These systems are learning patterns about patterns. They're discovering rules about how the world works that nobody explicitly taught them. And that's when things get really wild. Here's what I call the prediction gap. Every time a machine learning system looks at something new, it makes a prediction. It takes its best guess based on everything it's learned so far. Maybe it's Spotify guessing whether you'll like a new song. Maybe it's your email figuring out if something's spam. Maybe it's a medical AI looking at an X-ray trying to spot pneumonia. The system makes its prediction. Then it finds out what actually happened. Did you skip the song in 3 seconds or play it 5 times? Was that email actually spam or something important you wanted? Did that X-ray show pneumonia or not? That gap between what it predicted and what was real, that's where all the learning happens. It's like when you're learning to shoot basketball free throws. You don't get better by making every single shot perfectly from the start. You get better by missing, then adjusting. You shot too hard? The ball clanged off the back of the rim? Okay, less force next time. You shot too soft? Didn't even reach the hoop? More force. Your brain is constantly measuring that gap between where you wanted the ball to go and where it actually went. Machine learning works the same way, just way faster. If Spotify shows you a song it thinks you'll love based on your history and you immediately skip it, that's useful information. The bigger the surprise, the bigger the gap between prediction and reality, the more the system adjusts. It's learning that whatever pattern made it think you'd like that song, maybe that pattern isn't as reliable as it thought. This matters because most people think AI systems are just really good at following rules. But these systems are doing something way more sophisticated. They're building their own understanding of cause and effect. They're creating their own internal models of how things work. And they're constantly updating those models based on every mistake they make. Think about Jake. Jake's trying to teach his dog, Max, to sit. Jake does what everyone does. He says sit while pushing Max's butt down. He does this like 20 times. Max doesn't really get it. He sits sometimes, but it's random. Jake thinks he's teaching Max the command. But Max has no idea if he's supposed to respond to the word, the hand gesture, the push, or the treat Jake's holding. Now watch what happens when you apply the prediction gap principle. Instead of trying to teach Max a rule, you let Max make predictions and learn from mistakes. Max jumps up on you. You turn away and ignore him. Max's prediction was, jumping gets attention. Reality was, jumping got me nothing. Gap registered. Max adjusts his strategy. Next time he sits, you immediately give attention and a treat. Max's prediction was updated, and his behavior changes based on that feedback loop. That's exactly how machine learning works. The system isn't memorizing rules. It's building a strategy based on what worked and what didn't. But here's where it gets interesting. There's this pattern I've noticed called the invisible error. This is when a machine learning system is making mistakes, but in ways that are really hard for humans to spot. Your YouTube recommendations seem pretty good, right? You watch a lot of what it suggests, but here's what's actually happening behind the scenes. YouTube's algorithm is making thousands of tiny predictions about you every single day. Most of them you never notice because they're invisible. The video it almost showed you but didn't. The thumbnail it tested on you for 0.2 seconds before switching to something else. The subtle change in how it ranks your search results based on what you clicked yesterday. Each of those is a tiny experiment. Each one is the system making a prediction, seeing what you actually do, measuring the gap, and adjusting, but you don't see the mistakes because they happen in the background. You only see the final result, which keeps getting more and more accurate at predicting what you'll click on. This is fascinating because it means these systems are learning things about you that you might not even know about yourself. YouTube might discover that you watch more videos about dogs when you've had a stressful day. Not because someone programmed that rule, but because the algorithm noticed a pattern. On days when your watch history shows certain signals, maybe you watched several short videos in quick succession, or you came back to YouTube multiple times in an hour, you were slightly more likely to click on and finish videos featuring animals. That's an emergent pattern. Nobody taught the algorithm that stressed people like dog videos. The algorithm discovered it through millions of tiny mistakes and corrections across millions of users. Here's what makes this even more surprising. The system doesn't understand stress or dogs or comfort the way you do. It just knows that certain mathematical patterns in your behavior correlate with certain mathematical patterns in which videos you'll watch. It's like how you can predict it's going to rain by seeing dark clouds without understanding meteorology. The algorithm sees patterns without understanding meaning. This connects to something even deeper about how learning actually works. Whether you're a human or a machine, you can't learn without making mistakes. That sounds obvious, but think about what it really means. Let me tell you about Sarah. Sarah's been trying to learn Spanish for about 2 years now using one of those language apps. She does her lessons every day. 20 minutes, never misses. But here's what Sarah doesn't realize. Her app is designed to let her succeed. Like, a lot. If she gets something wrong, the app immediately shows her the right answer and moves on. She feels like she's making progress because she's getting through lessons. But Sarah can barely have a basic conversation in Spanish because her brain never really had to struggle with that prediction gap. Every time she made a mistake, the app smoothed it over so fast that the learning never stuck. She never sat with being wrong long enough for her brain to really adjust its understanding. Now compare that to Marcus. Marcus started learning Spanish around the same time, but Marcus uses a different approach. He watches Spanish TV shows. No subtitles. He understands maybe 30% of what's happening. He's wrong constantly about what people are saying. He makes guesses. Most of them are hilariously incorrect, but something interesting happens over time. Marcus's brain is in constant prediction gap mode. He guesses what a word means based on context. He's wrong. The plot proves he's wrong. His brain adjusts. He predicts what's about to happen in the conversation. Wrong again. Adjustment. This process is uncomfortable. He feels dumb. But after 6 months, Marcus can actually have conversations. His brain built a real understanding of Spanish by constantly being wrong and correcting itself. Notice how Sarah felt more successful but learned less? While Marcus felt like he was failing constantly but actually built real skills, that's because learning happens in the gap between prediction and reality. The bigger the gap, the more adjustment happens. Sarah kept that gap small and comfortable. Marcus let it be big and uncomfortable. That's exactly what machine learning systems do when they work well. They deliberately put themselves in situations where they'll be wrong often, so they can learn faster. Now here's the sneakiest part. There's this thing I call the confidence trap. This is when a learning system, human or machine, becomes really confident about its predictions in exactly the wrong way. Here's how it works. Imagine an AI system learning to identify pictures of dogs. You show it thousands of images, dogs of every breed, every color, every size. The system gets really good at it, like 98% accurate. It's learned the pattern of what makes something a dog: fur, forelegs, tail, certain shapes of faces, certain poses. But then something weird happens. You show it a picture of a wolf. The system is super confident it's a dog. Not like maybe it's a dog confident. It's like 95% sure this is a dog. Why? Because wolves match almost all the patterns the system learned about dogs. But they're not dogs. The system is confidently wrong. This happens because the system learned to recognize patterns in the training data, but it doesn't really understand what a dog actually is. It just knows things that look like this in images tend to be labeled dog by humans. When it sees something that matches those visual patterns even more strongly than some actual dogs, it becomes even more confident, even though it's wrong. Your brain does this too, by the way. You meet someone who reminds you of your friend Tom. They have similar mannerisms, similar laugh, similar way of talking. Your brain is highly confident it knows what this person is like because they match the Tom pattern so well. But they're not Tom. They might be completely different. Your brain just got confidently wrong by matching patterns too strongly. This matters because as AI systems get more powerful, they don't always get more accurate in ways you'd expect. Sometimes they get more confidently wrong. They find stronger patterns in their training data that lead them astray when they encounter something slightly different. But here's what nobody wants to admit. This isn't actually a flaw in how machine learning works. This is a fundamental feature of pattern-based learning. You cannot build a system that learns from examples without also building a system that can be fooled by things that look like the examples but aren't. Think about what's really happening here. These systems aren't learning truth. They're learning correlations. They're learning what tends to predict what in their training data. And in the real world, correlations are messy. They break, they mislead, they work 99 times and fail catastrophically on the 100th time. This is why Tesla's self-driving features sometimes mistake the moon for a yellow traffic light. The system learned that big, bright, circular, yellowish objects at a certain height in its field of vision predict traffic lights. And the moon, under certain conditions, matches that pattern really well. The system's confidence is based on pattern matching, not on understanding what the moon is versus what a traffic light is. What's actually happening behind all of this is something that changes how you think about intelligence itself. Machine learning revealed that intelligence might not be about understanding truth. It might be about predicting what happens next based on patterns you've seen before. And the better you get at predicting, the more intelligent you appear. Your brain does this constantly. You don't really understand how language works at some deep level, but you're incredibly good at predicting what word comes next in a sentence. You've seen millions of sentences. Your brain learned the patterns. When someone says, "I'm going to the," your brain instantly generates predictions. Store, bathroom, park, beach. It's filling in based on patterns, not understanding. GPT and other language AI systems work the same way. just mathematically. They're prediction engines that got so good at predicting the next word based on patterns in billions of text examples that they appear to understand language. But they're doing the same thing your brain does, pattern matching at massive scale. And once you see this, you can't unsee it. These aren't thinking machines. They're incredibly sophisticated pattern matching and prediction engines that learn by making mistakes and adjusting, just like your brain. This isn't just about machine learning. It explains everything from why you can't learn guitar without hitting wrong notes 1,000 times, to why kids who are constantly corrected and protected from failure often struggle more as adults, to why the best chess players aren't the ones who studied the most rules, but the ones who played the most games and lost the most often early on. The people who succeed at learning anything, humans or machines, don't avoid mistakes. They create environments where mistakes are frequent, visible, and quickly corrected. They maximize the prediction gap. They stay in that uncomfortable space where they're wrong often enough to keep adjusting their understanding. So here's what we've uncovered. Learning isn't about memorizing rules or following instructions perfectly. It's about building prediction engines through repeated cycles of guessing, measuring error, and adjusting. Whether that's your brain learning Spanish, or your phone learning your face, or Netflix learning your taste in shows, the systems that learn fastest aren't the ones that avoid mistakes. They're the ones that make mistakes in smart ways. Mistakes that reveal which predictions need adjustment. They're measuring gaps between expectation and reality constantly, and they're updating their internal models based on those gaps. Plus, these systems aren't learning truth. They're learning correlations and patterns, which means they can get confidently wrong when they see new patterns that look like old ones but aren't. This isn't a bug, it's how pattern-based learning works at a fundamental level. And that deeper pattern we talked about intelligence being prediction rather than understanding, that explains why these systems can seem so smart while doing something completely different from what we think of as thinking. The question isn't whether machines can truly learn. They obviously can. The question is whether you'll recognize these same learning patterns in yourself. Because now you know that your frustration when learning something new, that feeling of constantly being wrong, that uncomfortable gap between what you predicted and what actually happened, that's not failure. That's literally how learning happens. You can't avoid that gap. You can only decide whether to stay comfortable in what you already know, like Sarah with her language app, or deliberately put yourself in situations where you'll be wrong often enough to actually learn, like Marcus with his Spanish TV shows. Because once you see that learning is just sophisticated mistake making, everything looks different. That error message isn't annoying, it's information. That failed attempt isn't wasted time. It's adjustment happening. That embarrassing moment when you got something wrong, that's your prediction gap doing exactly what it's supposed to do. So next time your phone recognizes your face in weird lighting, or Spotify plays exactly what you needed to hear, or you finally nail that skill you've been practicing, ask yourself, how many mistakes did it take to get here? Because the answer is always the same. Thousands, maybe millions, every single one, teaching the system, whether silicon or neurons, how to predict just a little bit better next time.